We have a new task over here where we need to find our x in order for us to get our H2S. So in solving for your S2S over here, let me rewrite it again on the left side. So S2S is equal to SF plus X SFG. And because we are looking for your x, let's rearrange that again, so it's becoming S2S minus your SF over SFG. And all these value are going to be read from table A5 at 50 kilopascal. So let's have a look at our property table here. So we have table A5, and at pressure 50, what will be the combination of our S? So we have this one over here. Let me copy paste it first into our notes over here. Okay, and rewrite it into this mathematical expression. Substitute all these values. So this is your SF. Okay, put it here. Your S2S is coming from equal to S1 that you get over here. Okay, so plug in the value, and then you have your SFG coming from this part over here. And that will give you X2S is equal to 0.8984. And next, what are you going to do is you are going to make use of this X, right? This value, and substitute it into these equations over here to obtain your H2S. And let us do that. Same goes with your entropy S over here. You will still need to get your HF and HFG at 50 kilopascal, right? So let's go to our property table over here. At 50 kilopascal, the range value of your HF and HFG is this one, and we copy it into our notes here. And let's finish the mathematical expressions. All the value over here, and it will give you H2S. So remember, our main objective in the first place is to find the isentropic efficiency, and we are going to make use of these equations over here, right? Equation 2 over here, to find our isentropic efficiency. So I'm going to rewrite these expressions down there. Okay, so we are going to paste it in here. Oops, sorry. I'm going to bring it down here. Okay, let's do the mathematical expressions. Take your H2A directly from this one, which is 2682.4, 2682.4, and minus with your H1 that you got from here, 3231.76, 3231.76, divided by your H2S over here. So you have 2411.082 minus with again 3231.76, and you are going to time it with 100 and see what did you get for that. You get somewhat around 66.939, or rounded adjustment to 66.94%. So this is the answers for your new turbine, or we call it as isentropic efficiency of your turbine. So next, we haven't finished yet because we need to proceed to the P part where you need to find your mass flow rate. So again, we have another equations over here, and also this right over here. It's already given, so it is best if we make use of equation 1 instead of the above this one. So let's rewrite negative 2000 kilojoule per second is equal to m dot, the one you are going to look for. And now your H2 is actually the actual one, right? This value over here. So you are going to have 2682.4 minus with your H1 up here, 3231.76, and the unit is in kilojoule per kg. So this one is in kilogram per second. Okay, so we do the mathematical arrangement so that finally you will get your m dot. The answers must be in kilogram per second. Let's do that. Using the mathematical expression, you will finally get your m dot is equal to 3.64 kilogram per second. We already get the m dot value, which is 3.64 kilogram per second. So we have completed both questions. The first one to find the isentropic efficiency, which is equal to this one, 66.94%, and number 2 is to find your mass flow rates, where you got 3.64 kilogram per second. I would like to recap, right? Before you solving for this activity, you need to at least have a look at this checklist over here. And also, when you have an isentropic efficiency problem, please note that the inlet part must be equal to the isentropic part, which is S1 is equal to S2S. Then you will need to make use of this to find your H2S over here. And once you solve for this, then only you will get the isentropic value before you can count for the isentropic efficiency. So this is how you solve for turbine device with working fluid, steam type of working fluid. Thank you.